Hello everyone, and thanks for joining us for today's webinar. My name is Christian George, and we're going to walk through a discussion today called How to Use Predictive Analytics to Drive Sales and Delight Your Customers. I'm joined today by our Kiva COO, Sujit Singh. Sujit, thanks for joining us. And over the next hour, Sujit's going to share a proven process that's helped our customers create additional sales opportunities and build customer loyalty at the same time. So thanks again for joining us. And listen, we understand there's a lot of pressure on you as supply chain professionals. There's 1,000 other things that you can be doing right now. There's tons of things that are occupying your time and attention, but you chose to show up and invest in yourself and your team. So thank you again for joining us. Now, if you're anything like our customers, then you might have some of these questions going through your mind all the time. You might be constantly thinking about, how can we make things better? Can we create additional sales opportunities? Are we delivering a great customer experience? Do our customers actually like doing business with us? And then finally, how can we get rid of all this excess inventory? And that's a lot to worry about, on top of all your other responsibilities at work and at home. And that's exactly why we're here today. That's why we put together this webinar. We want to help make your job easier so that you can relax and know that things are running smoothly. And we believe that this material we're about to share, it's going to help you move in that direction. But before we get started, I want to do this cool little feature we have on the webinar. I'm going to ask you a question. And I want to know, why did you register for today's webinar? So I'm going to launch that poll, and you'll be able to see it right there. Please go ahead, take a couple seconds to fill it out. And I'm going to share those results. Great. So thanks everyone for sharing. It looks like we've got kind of a mixed draw here, and a lot of you thought that 50% of you thought the topic was interesting. 31% think that your company can be more proactive with your customers, and then others specifically some other specific concerns. So whatever your answer is, that's okay. It's important for us and for all of us to know why we're doing something. So we want you to kind of get thinking, get thinking about that beforehand, so that you can get the most value out of this experience. So if you have any questions or concerns throughout the webinar, we want to make sure this experience is good for you. If you can't hear us or you can't see our screen, please send us a chat. You can see it's highlighted there in the yellow box and the pink script or the pink highlight, as well as questions that come up throughout the webinar, and we'll have a question and answer time at the end. You can submit your questions in the question feature as well. Also, finally, before we get into the agenda, at the end of the webinar, you'll have an opportunity to fill out a survey. Please take the 30 seconds to fill out the survey. It's really important because if we don't know how we're doing on this end, we're not sure if the information you're receiving is helpful, then we're not going to be able to make this better for you. So please take the time to do that, and we thank you in advance. So let's get right into the agenda. First things first, Sujit's going to just introduce our Kiva to you, who we are, what do we do. Then he's going to talk about the backstory of how this all came about and the approach that we used to create this technique. Next, he's going to talk about the actual technique proactive sales approach that actually delights your customers. And the second approach is a cross-selling opportunity. Next, he's going to give a live demonstration using Arqiva Sales Predictor, so stay tuned for that. And then finally, we're going to wrap it up with some questions. So if at any point in time, like I mentioned, you have questions, just submit them or write them down, however you want to do it, and we'll get to those at the end. All right. So at this point, I'm going to turn it over to Sujit.
Thank you, Christian, and welcome everybody. Let's get right into it. And as Christian pointed out, let's begin with a few slides on Arqiva. Arqiva has been in business since 1993. We were founded by ex-DuPonters, so we have been from the very beginning providing software and services solutions around the idea of supply chain planning. We are currently into the 4th generation of our software programs, and we provide software in the area of supply chain planning, very specifically in the extended area of sales and operations planning. And as you can see on the slide, we provide many different modules: segmentation, demand management, inventory, supply and capacity planning, scheduling, visibility, and S&OP in general, being a lot of those. Over the years, we have been identified by multiple organizations. We are on Gartner Magic Quadrant. We are a Microsoft certified partner, and we do take advantage of a lot of other technology platforms that are available in the marketplace. A quick collage of our customers' footprint in terms of geography as well as our footprint. So as you can see, we have customers throughout the world, and in order to support that, we have offices in different time zones as well. As mentioned earlier, North America is our headquarters. We are out of Wilmington, Delaware, and in Europe, we are in Antwerp, Belgium, as well as in Mangalore, India. And in Europe, we also have a very strong partner who does Arqiva implementations, and they are named Solventure, and they are based in Ghent, Belgium. Quick collage of some of our client logos, or at least the ones we have permissions to put on a board. As you will notice, the left-hand side column is chemical and process industry focus. That's where we got started, and that's where we have the biggest footprint even today. Over the years, it's certainly in the very beginning, that's all the work we did, but maybe after the first 5-6 years, we started to branch out, and over the years, we have built a reasonable client base in discrete as well as in food and CPG industries. So hopefully you are able to recognize yourself in one of those columns. Right, so let's get to the topic for the day, and let's frame it in the way we see the world. As mentioned earlier, we do different modules with different clients. While everything is grouped under this concept of sales and operations planning, we might have a customer where we implement just the segmentation or just the demand, or segmentation and demand, or really any combination of any of these boxes. Today's presentation is on demand generation and shaping, and as such, it completely fits inside the demand box. The idea is to shape the demand, to generate some extra demand, and as such, it's part of the overall concept of demand management. So let's define some terms first. What is demand generation? Well, demand generation is your classic demand generation. You want to make awareness in the marketplace. You might have targeted marketing campaigns. You might have targeted sales processes, whether it's person to person, whether it's business to business, whether it's e-commerce based. All those are ideas around demand generation. And every once in a while, companies always do demand generation, but every once in a while they might execute special techniques which are called demand shaping, which have to do with near-term shaping of the demand, either increasing or decreasing the demand through certain steps. So let's define that next. The idea of demand shaping can be summarized as the attempts to influence or manipulate demand for a company's specific products to match the planned supply. For example, if I have too much inventory of a particular product, I might want to do a quick deal so that I can get that moving through my supply chain. These are typically performed through pricing incentives, cost modifications, product substitutions, things of that nature. As a consumer, whether you know this phrase demand shaping or not, you probably have seen this in the real world by way of a lot of buy one, get one free, or half off, or any of these special kinds of promotions, because those are attempts to shape the demand in the near term. So, as consumers, we have seen this in the retail environment. I will go ahead and actually give them a pass and say, retail absolutely gets it, but how is this done in a B2B environment? That's the question we would like to address in this session. And for those of you who attended my previous webinar, well, first of all, welcome back, but also just to make sure you don't see the slide and think we are on the same presentation, this slide here represents extended supply chain. If we start all the way to the right, that represents the consumer, you and me, if you will, and that, that demand that we express onto the supply chain progresses backwards through the stores, then the regional warehouses, and then various levels of manufacturers. This supply chain can be very long in the sense that it can be a 6-month lead time or even longer lead time to go all the way from the left to all the way to the right. And there are inefficiencies built in which basically create a lot of waste all throughout this extended supply chain. And studies have shown that up to 6 months of inventory can be trapped between the customer and the ingredient manufacturer, basically the two ends of this graphic. If you are towards the left-hand side of this chain, you are probably seeing some of these effects, and the question then becomes, how can we get rid of this inventory? How can we get rid of this inefficiency? So some of what I'm going to present is going to discuss that as well. Now, how did we come across this idea? So a little backstory. One of our customers called us and suggested that they got a very interesting call a previous day from a local retail operation. And the retail operation, just based on data that they kept, or maybe just by force of the person's personality involved, I had been keeping track of the usage rate. And because the relationship was such that they could call them, they called this particular customer and asked them that based on their typical usage rate, it must be time for them to get the product again. And so the customer was happy with that, but then they asked the question, why can't we do this in my business? My business has other large companies ordering from me, and we would like to make sure that we have a proactive approach so that we can call our customers. This tells them that we are thinking about them. And if we can then get in some orders that are going to come in, let's say a week from now, if we can expedite some of that, if we are more proactive, it will make customers happy. It will even increase our sales in the near term. We can actually shape our demand. And so after some discussion, we agreed that it can be done, and that's where we set out to do this work. And that's where it got started. That's the story behind it. So how did we approach this, and how do we recommend people approach this? The first thing we did was we tried to sit down and say, what are we trying to accomplish? What are our goals? And the question in this very specific case was, we wanted to shape the demand, if at all possible. So then the question became, are those opportunities available in this business? Is this a case where a customer would take the extra demand if that's what we were suggesting to do? In this particular case where we did this project very early on, the answer was yes. And so then we got into the thinking of what are the costs of taking action now versus doing nothing. And we recognized that the cost was significant, that the customer could very easily be going to some other place if we were not taking action now. So based on that, we decided that it was a worthy goal to pursue. And then we got into the nitty-gritty of it. We said, what kind of data would we need to get to this type of a result? So we quickly got to historical data, the data that represents the customer's demand down at the product level. And we wanted to get that data and compare that to the current situation, the latest situation, and basically make some recommendations about what to do and what not to do. Now, very quickly we recognize this is a statistical exercise. It's not the most predictable, cause and effect type of exercise. And as a result, we learned very quickly that more data is better. And that's one thing that I would like you to remember, that if you ever embark on such an exercise, that more historical data is better for the statistical purposes. And then once we had the data, we got into thinking, can we use this data to create the demand opportunities? And so that was where the chunk of the work happened. Now, when it came to data, the requirements that we envisioned included sales history, included any current open orders, any backlog, if some industries call it the backlog, and the current inventory. And while it is not always available in all the ERP systems, we also thought of getting data such as customer buying patterns and products that are purchased together. Now, if these data are not available, obviously, the purpose of this analysis would be to create the buying patterns, to understand and create a formula around the buying patterns, and to understand which products are purchased together. But to the extent that a company already had that data, that would be something that one would be interested in getting as a data requirement. Step 3 was around configuring the solution. So in the end, it turned out to be a very simple 3-step process. We basically said that once we have the data, we want to analyze it and look at the metrics, generate rather the metrics and the statistics based on the history. Once we had that, and we'll talk about what those statistics could be. Once we had that, one would get into an engine, an evaluation engine that would use very specific business rules and then begin to generate what you would call recommendations. You should do this or you should do that. And then finally, make that data available to the people who could actually execute. In many cases, that would be your CSRs or customer service reps. It could also be people like the internal sales organization. And in some cases, it could be the external sales organization, the people who actually go and visit the customers. So those were the 3 steps that we decided to work on. And just to keep the goal in front of us, we basically said, what exactly are we solving for here? And so the types of things that we were solving for were, are there additional sales opportunities available in this particular supply chain? That was the key thing that would allow us to shape the demand. And then we also wanted to ask, are there things that are missing? The orders that should have been in by now, have they gone missing? Meaning, has the customer gone somewhere else? Are they just delayed? Those types of things as well. So both additional sales as well as pulling in delayed sales to this moment. So let's look at some examples. And first thing I would like to do is walk you through some idea of what customer buying pattern examples would look like. So here, let's look at an example of a customer. I've named him Steady Eddie. This customer, without fail, orders 50 units every single day. So if you look at the graph starts on day 1, ends on day 30, in terms of the historical data that is available, and days 31 through 36 are all zeros. And in this case, however unrealistic you might seem it is, but this customer, for some reason, is ordering exactly 50 units every single day. So now, if we have this demand pattern, and if you do in your business, probably That's very good, and probably the rest of the webinar will not be very interesting if all your customers are this steady. But to the extent we have this data, some questions that we can ask ourselves. What, for example, might be the expected demand on the 31st? So if you notice, from day 1 till day 30, this customer has ordered 50 every single day. So I could just say very easily that the expected demand on day 31 is 50. And then the follow-on question would be, what if no demand shows up on the 31st day, the customer does not order? Do I panic or not? And how about 32nd day, followed by no show on the 31st day and 33rd day? When is it in a B2B environment that we would begin to wonder what happened to this customer and take some actions? And what might those actions be? For example, in B2B world, that might very well be that we have to call the customer. So when do we do that? Well, in this example, certainly on day 31 itself, someone would not be misplaced or mistaken in calling this particular customer. But by day 32 or day 33, so 1 day or 2 day or 3 day gap, definitely there is some amount of very strong wondering going on as to what happened to this demand. So if we take this Steady Eddie example and add an element of surprise, let's say Steady Eddie has been going at 50 units a day every day for 29 days. On day 30, he actually orders 150 units, so 3 times the usual demand. Now the question becomes, what is the expected demand on the 31st? One thinking would say, well, since the typical pattern is 50 units per day, we would expect 50 units of demand on the 31st. A different answer could be that this customer needs 50 units per day, but has recently changed or just changed their buying policy, so they are actually buying stock enough for 3 days in advance. And that means that we do not expect any demand on the 31st. So again, if we take this type of a pattern and begin to ask the same question, what if no demand shows up on the 31st or the 32nd or the 33rd? When will we call the customer? Again, we are trying to establish these questions, and hopefully we can then create a business rule which will allow us to answer these questions. Let's look at now a somewhat more realistic Steady Eddie. So this customer is mostly steady, but you will see that there are some variations, which is par for the course in most business environments. And in this case now, maybe the average is still very close to 50, and we can also see that this customer is ordering pretty much every day, but certainly it's not as predictable as the previous example where it was exactly 50 every single day. Again, we can go through a very similar exercise of thinking, what is the expected demand on the 31st? Well, in the previous example, the Steady Eddie, the expected demand was known, it was 50. But now we are going to have to calculate things like averages and standard deviations and those statistical measures, very simple statistical measures, to say what might that be. And that obviously the most simple exercise is to say it will be the average across these 30 days. And the question about when do we begin to get antsy, when do we call them, what happens if the demand doesn't show up on 31st day and the 32nd day and the 33rd day, now it becomes a little bit more of a statistical exercise and a statistical inference drawing exercise. Third example, this is actually a very Steady Eddie as well, in the sense that even though it looks different, this customer is not ordering every day, but it looks like they order every 3rd day. So maybe they do something more fun on the other 2 days. Whatever their reason for having that gap, whether they go on actual vacation or not. This is also a very predictable data set. Every 3rd day, without fail, we get 50 units of demand. So once again, if we go back to the same types of questions, what is the expected demand on the 31st? When do we begin to panic? When should we call this customer? Certainly in this example, because the last demand is on day 30, I do not expect any demand on day 31 or day 32, simply because I'm used to the 3-day ordering cycle. So I do not need to necessarily call the customer on day 31 and 32, and maybe on 33 or 4 or 5, 34 or 35, I might be actually willing to pick up the phone and call them. And then let's now maybe get into a very realistic situation. Here is a customer who is very, very unsteady, goes up and down, has a lot of gaps, very intermittent, very erratic. You can use the term that you like. And this customer probably represents probably is much closer to the data that we see in the real world. And it almost represents a random walk kind of data set in terms of there's just randomness built into it. And so if we were to try to draw some conclusions from that data set, now we are really into the realm of statistics, and we want to understand the expected demand, which is typically the average, but it can also be driven on the size of the previous order. And if we want to address the question, when do we call this customer about their missing demand? Now it becomes a more statistical exercise. Now, hopefully you will agree with me that a lot of our demand is on the more unsteady type, and therefore it does require us to run through some numbers, churn through some statistics before we can address the question when to contact this customer for the missing demand. So we earlier talked about the data that we have, which included the shipment history. Now I'm going to talk about what we should do with that data in order to try to get to the answers to the questions we just posed. So using the available data, specifically the sales history, we can calculate the following. We can calculate the typical order frequency of as well as the associated variability of a particular customer product combination in question. So in the example where the customer was ordering 50 units every day, the typical order frequency is once per day, and there is really, at least in the first example, there was no variability. It was always exactly once per day. In the more erratic examples, that frequency would be, the average would be something like 2.6, not an integer number, and there would be variability around it. Also, we could measure things like typical order quantity and the variability with it, because again, the steady Eddie example, it was always 50, but that's not very realistic. What really was happening, it happens in the real world, is that the order quantity moves up and down, and there is an associated variability with that. And based on that, we can calculate things like, well, what is the estimated average usage by this customer? If it makes sense, we can actually enhance this to also do things like estimated usage in a season, but that's a more, enhanced implementation of it, nuanced implementation of it. More importantly, based on the last order that they got, we can calculate things like what is our estimated current days of supply at the customer level, which days of supply is a measure which says, given if I have 100 units of demand and I consume 10 units per day, these 100 units are going to last me for 10 days. So based on the last order and based on the estimated daily usage, we can then calculate the current days of supply that might be left at this customer for this particular product. So now, once we have those simple or relatively simple statistics established, we then look at the lateness score. And so here is a picture on the black bar all the way on the left is the last order. This is what the customer took from us the last time they took any products from us. So that represents an amount as well as the time. And in the blue x-axis, the arrow, if you will, represents the timeline. So here, the last order happened on a particular day, and if we apply a very simple thinking of what is the average order frequency, we can project when we can expect the next order. That's represented by this green line. This orange line, it represents if they take 1 standard deviation more time to order, so average plus 1 standard deviation, which is kind of one way of saying they're running a little bit behind. That represents that time. And then the red one represents average plus 2 standard deviation, which is very late. Now, whether we use 1 standard deviation, 2 standard deviations, half, 1 half, 2 halves, how many cuts of the data we want is really dependent on the precision in your data and the data volume. But just to explain the concept, let's just go with these 3. So we have a zone of time which is within the average order interval, which is to the left of the green line. We have a zone of time which is between the green line and the orange line, and that is representing this area where it's slightly late. We have a zone between the orange line and the red line. This is where it's quite late. And then we have a zone outside of the red line, which is very, very late. Now what we can do is assign some kind of an objective scoring methodology where I'm calling it the lateness scores. And we are basically saying that if it is within the first zone, it's not late, and we give it a score of 0. And then second zone, we give it a score of 1 and 2 and 3 respectively. So the idea is that we are saying that the more to the right you are on this time scale, the more late you are, and therefore you get a much higher lateness score. Very simple. Now we will calculate the lateness based on the usage rate. So remember, we said that based on the data that we have access to, we can calculate the average usage rate. So again, same type of schematic. Here is the last order, and we have the time scale. Since we know the average usage rate, we can calculate when that last order will run out if they use the product on an average usage rate basis. So if they use on average 10 units per day, and if they had ordered 100 the last time, then in exactly 10 days, we expect them to run out of the product. So where this green bar hits the timeline, that's the time where we are saying they will be running out based on the average usage rate. Now, we would have no real way of knowing if they are using it faster than the average usage rate, but to the extent that we can project this idea that maybe every once in a while they do not use as fast as the average, maybe they do use it slower, we can project a different line, this orange line, which represents the average -1 standard deviation usage rate, which is saying they are using the product slower than usual or less than usual. And then we can similarly extend it to the average -2 standard deviation usage rate. So again, in terms of an alarm rate, if an order has not come in before the point of time where the green line meets the time axis, we are not very concerned because on average basis, we are okay. Then if the order doesn't come in between the zone between the green line and the orange line, that's where we are basically going to say, well, even with considering the fact that they sometimes use it slow, it does look like they are a little bit behind in their ordering. And then between the orange and the red line, it's further behind. And of course, to the outside of the red line, it's very, very behind. So we can take this type of thinking and again assign lateness scores to this idea, 0 being we are not concerned, 3 being we are very, very concerned. So 2 simple analysis, 2 simple lateness scores, and then we can begin to put them together. So then we ask the question, well, where are we today? We have the historical data, and the historical data tells us the zones in which to think, which is 0, 1, 2, 3 on one analysis and 0, 1, 2, 3 on the second analysis. And now what we want to say is, where are we with respect to a particular customer and a particular product? So it could be possible that for a particular combination that we are looking at, the score is 0 on both fronts. We are not late in terms of the order frequency, as well as we are not, based on the amount they ordered, we don't think they would have run out by now based on their average usage rate. So we assign a score of 0 to both metrics, and the total score simply becomes 0 plus 0. If this were the case, fantastic. Let's call it a day. Let's go home, have some fun. If this were the case for every single combination. Obviously, that will not be the case. We will have different combinations where different things might be happening. For example, here's one where based on the order frequency, it looks okay. That's the graphic on the right. We get a score of 0. Excuse me. We get a score of 0, but based on the usage rate, And based on the fact that they maybe ordered a smaller amount the last time they ordered from us, they should have run out by now. So the total lateness score is no longer 0, it's actually 1 plus 0, which makes it 1. So it's a little bit more severe condition than the previous one, a little bit more bothering, if you will, bothersome, but maybe not as much as the next one where the scores are higher. So now in this example, the left-hand side metric, which is based on the usage rate, is still on 1. Maybe we are okay. We think that because they made a larger order last time, they should still have the product available. But in terms of the order frequency, we are way behind. We now have a score of 2 over there, and that gives us a lateness score of 3. Now, obviously, permutations and combinations kick in. We can go through many, many combinations. I'm just going to go all the way to the right. We'll say there is certainly a possibility that there's a customer who is way late based on frequency, way late based on the last order, as well as the calculation of when would they run out, and that gets them the maximum score of 3 plus 3 equal to 6. Now, in terms of who should I call, the idea is very clear. Anybody who gets a score of 6 should be called yesterday. Maybe someone who gets a score of 4 should be called today. And maybe the zeros and ones can simply be ignored. Maybe they are within the norms, normal fluctuations, and we do not have to worry about that, at least not right this moment. So this was the idea of calculating the score, and then drive the actions through that, and you can come up with your own business rules about when we should call them, should we call them, who should call them, should it be CSRs, should it be the internal salesperson, should it be the salesperson who calls on them, should it be a trip out there, should it be a phone call. Those are business rules that one establishes in terms of the actions. Now, when we did this work, and when we do this very often, this is where we start, but you can then, of course, get more out of the same analysis. So you can get things like customers who used to order but have stopped. How will we know that? Well, if the number of standard deviations that you are looking at from the last time that they ordered, if there are 3, 4, 5 standard deviations out, then it's obvious that something bad has happened, and maybe they have found another supply source, maybe they have stopped making that product, maybe they have then done some substitutions. It is a good point to call them and ask them why that might be the case. Another similar example could be they used to order regularly, maybe once every 2 days. Now they order once every 10 days. The amount really has not changed. Well, now becomes the question, why? Has your business slowed down? Have you changed your manufacturing so you do not use this product anymore? Or are you buying from someone else? Whatever the case might be, there might be business opportunities in terms of renegotiating, or certainly creating a closer relationship with the customer. So these are some of the other things that the same analysis can identify. One of the other outputs can be cross-selling opportunities. So we are all familiar with the e-commerce landscape today. Here are a couple of screenshots from Amazon. So on the left-hand side is a product actually from one of our customers. It's a beard and facial wash. And you will notice at the bottom of the screen, they give you some cross-selling hints. What they are saying is that when people buy this product, they frequently also buy some other facial washes or beard accessories, if you will. And so they kind of encourage a customer to go ahead and buy a little bit more. On the right-hand side is an example from one of our other customers, SunSweet. They also, if someone wants to buy their dried prunes, then they immediately suggest that others who bought dried prunes also bought this other fruit that is shown in the picture there, dried fruit. So this is something that we have seen in the e-commerce landscape, and it's actually quite effective in generating some extra demand, some cross-selling. In the B2B space, once we have the data that I talked about, we can generate a very similar type of analysis and get to similar types of conclusions. So here, for an upstream B2B manufacturer, if we have the data set from the ERP system, we can do the market basket analysis on their data, which is just a specific way of saying, which products are bought together. And we can report to them that, hey, Mr. or Ms. Customer, you are right now buying from us this product called bulk product 000196. And by the way, 93% of customers who bought this product from us also bought the product 0026. And 47% also bought product 425. And 40% also bought products 177. This type of analysis can be a very interesting output from the analysis of the demand history. And then you can use this to coach your CSRs to say to the customer, shouldn't you be buying this product? What is it about these products that other customers buy it when they buy the 196, but you don't? It's obviously the case that not everyone will latch onto that idea, but it would create an interesting conversation, and maybe, and in some cases we have seen this, it does turn into where the customer basically says, yes, I'm buying it from a competition, and maybe, yes, I will look into buying it from you. So those are some other advantages that you get out of the cross-selling analysis. So cross-selling obviously helps in identifying additional demand with the existing customers. You can actually, if possible, it might not always be possible, but you can create incentives to buy the products together. And then, of course, you can marry this with the idea of what is sitting in inventory. So now, not only can you suggest that others buy it, you can actually tie that to the idea of, by the way, they buy it, you should buy it, and, oh, by the way, it is sitting in inventory, so here, you can have it pretty much immediately. So now that, again, gets into the increasing of the sales and delighting your customers. Right, so we have looked at some of these examples from the perspective of demand shaping in the B2B world and using predictive analytics on your historical data, which can be a lot to generate extra demand. So what are the benefits? Well, the obvious one is more sales opportunities means increased revenue. In our experience, the customers who have used it have reported significant multi-million-dollar extra sales in the first month of go live, which is quite impressive. The overall customer experience is enhanced. We have examples where senior officials, CEOs, C-level officials from our customers' companies have called our customer CEOs and suggested that they were the only ones doing this type of analysis on their data, that they really appreciated the fact that they wanted to make sure they had the right product at the right time, and they appreciated the partnership. Very strong in terms of generating long-term relationships. In some cases, that resulted in single source supplier relationships being formed towards our customers. Shaping also means more control over supply chain. You can control which products you want to push into the supply chain and which you would rather not. Typically, the ROI is pretty large, as I mentioned, multi-million extra sales in the first month itself, which more than pays for a project like this. And then, obviously, all of this leads to competitive advantage in the marketplace. So those are some of the advantages that we have seen, some of the benefits we have seen. So now, let's put it all together. We want to not suggest that we don't do the basics. So the basic demand management always entails forecasting, and we definitely say that as best as we can, we want to suggest please forecast accurately. We are not changing that. But then once we are there, we can incorporate this idea of demand shaping as needed and as available to us. In fact, this is where we can also apply other ideas such as the previous webinar, which was on demand sensing. These are additional things that you do once your forecast is as accurate as you can possibly make it. Of course, it will be. There are some limits as to how accurate a forecast can be. We recommend working smarter, being smart in implementing this. While this analysis is relatively easy, depending on the business you are in, It might be difficult to perform it in Excel just because of the volume of the data. And it allows you to get more out of your ERP implementation. What we mean by that is that if you have the ERP, which SAP, whether it's SAP or Oracle or anything else, you have all this data, historical data sitting around. You're using it in some ways. This allows you to get more out of that data that you have collected over the years in your ERP system. So now we will transition to a demo. Well, as people are thinking about the questions, maybe I surprised them by putting the need for questions right in the middle. Let me take 2 minutes and go through the live demo, and then we can come back and do the questions in a little bit. So here is a quick demo of the software with some made-up data. This is so when we do this type of a project, you want to make sure that you plan ahead. So you will notice that we got this data at a very detailed level. We know which business, sales organization, distribution channel, who the CSR is, who the sales manager is, who the salesperson is. And we are basically ultimately calculating this field called the call now. The yes 6 means we would like you to call them now, and that is the most severe setting, and the most easy one is no need to call because we know that this customer does not need it from us. And the way the system is presenting the data to the user, we are basically saying for any combination, for example, here is a material 1311. We are looking at a particular ship to, the CSR, there is a particular CSR, and so these are the descriptive attributes. And the system is presenting what does the average daily demand look like on a day-by-day basis. What do we think from our past usage? What do we think they calculate? What does the average cycle look like? This example is quite severe. It looks like they all order more than once a day. Based on our last shipment, which is shown here, how much do we think is in the tank, so to speak? How much do they have still? In this case, that's a negative number. As a result of the fact that it is late based on the order frequency, as well as it is run out because of the fact that what they ordered the last time, based on their average usage rate, would not have lasted so far. We are giving them a score of -3 on the lateness, 3 on the run out, gives us a total score of 6, which is why you will notice that the arrow on this call now button is all the way to the right. And that arrow is indicating they should call them right now. And so I filtered here to only those that are marked as call them right now. Of course, we could have done this report at a different level and it would show areas where they do not need to be called right now. So let's scroll down on this list and look at something maybe a little bit slightly different. So here is another one. This customer, 1110, for this material happens to order 4,000 units a day on average, and their average cycle is about 5 days. And based on their last shipment and the last amount, we think they should have run out of this product 17 days ago. How do we know that? We know that because they ordered 1,000 units the last time. Their average daily demand is 4,000 units, and so they basically would have run out the same day. Of course, this is based on the analytics in the sense that we do not necessarily know exactly how much product they had on the day they ordered. So based on the analysis, the score is applied. They get a 3 on the lateness, the 3 on the run out. Net result, again, we get a data set where the call now score overall is 6, which is, again, that's what I have filtered on. I have only filtered the 6s. Now, depending on if the score was 0, the arrow would be all the way to the left, and 1, 2, 3, 4 would be in different areas in the middle. The bar here is trying to represent the very commonly used color schema of green, yellow, and red. So red obviously is indicating, an alarm that we should call them now. The system also has drill down capabilities. So if you, for example, were to click on the drill down feature, it immediately understands that you have clicked on a particular combination, and based on the place where you click, it actually generates the drill down report for you, where it shows you, a lot more detail about that particular combination. So for example, it shows you when was the first time we shipped to them, when was the last time we shipped to them, how many days has it been since the last shipment, and those types of data. Are there any open orders in the books? Because obviously you don't want to call a customer where they say, well, I already placed the order, it's in your ERP. So we want to track that as well. We do things like calculating things like the predictor ratio, which is a way of measuring statistically, do we have enough data so that we can say with some confidence that our analysis is doing a good prediction, or do we have just very minuscule amounts of data, in which case we cannot really hang our head in terms of on that predictive value of that data set. And then it generates graphs around what does the inventory picture look like. So in this example, they ordered 1,000. By this time, they would have run out of it, and obviously this inventory profile keeps going more and more negative based on the average usage profile. So I don't want to take a whole lot of time on it, but let me just say that even though I selected the call now of yes, this type of a system can be configured to show any and all kinds of data profiles, whether you just want the ones that are needing a call yesterday, whether you want to include the ones that are okay and do not really need a call. It becomes then a choice in terms of the users selecting which parameter they use in this particular dropdown. So that's how we have implemented it. And certainly, if someone is interested in a more detailed demo, we can get to that at a later point in time. Okay. So let's now really get to questions if there are any that have arrived. And Christian, why don't you lead us through that?
Absolutely. Well, thanks, Sujit. We do have a couple questions. The first question is, how long does an implementation like this take to actually bring to life?
If the data is available, this is probably something that takes 2 to 3 months. If the data is not available or the data is of poor quality, it can take a while. The implementation itself is relatively simple. The buy-in process is where it takes the most time, because if I'm not used to calling a customer just based on some data, I might actually want to go through at least a few cycles of distrust before I get to a trusting place with the analysis. And that's where the most time is taken.
Great, thank you. Second question is this something that we can manage in-house, or does it require constant oversight from Arqiva?
The places where we have implemented this, there is next to zero support needed from Arqiva. So I would say there is hardly any support needed. This is not one of your very complex optimization projects, so most of the clients are supporting this internally. At least in the case of 1 or 2 clients that I can think of, they have even taken this idea and extended the idea to other business units all by themselves. So it's really possible to support it by yourself.
Great. Well, that's all the time we have for questions now. I appreciate everyone for sending those in. So what's next? If you want to learn more about supply chain planning, this topic, or any other topic, please, we recommend that you visit our website, arqiva.com, as well as our blog, blog.arqiva.com. You'll find a ton of great information under our resources tab, so make sure that you check that out. Also, Sujit just showed you a live demo, but if you want to further dive into the Sales Predictor tool or any of our other tools here at Arqiva, you can request a demo on our website by just clicking that red demo request button and filling out the form, and we'll contact you, or you can just contact me directly at cgeorge@arqiva.com, and we'll make sure we get that taken care of. Finally, some dates to remember. We have our partner, Sylventure, is holding their next webinar on Thursday, May the 18th. Time is 7:30 to 8:30 a.m. Eastern Standard Time, and the title is Advanced Promotions Planning as Input for Financial Forecasting. So if you want to register for that, go to their website, solventure.eu. And then finally, our next webinar will be on Thursday, June the 29th, same time, 11 a.m. to 12 p.m. Eastern Standard Time. And the title of that webinar is Early Warning Indicators at Advanced Drainage Systems. So that's going to be a special topic, one that we're really passionate about here. So you can register for that on our website and look for emails to register as well. So that's it. Thank you all for joining us. Like we said, if there's anything that we can do to provide a better experience for you as a supply chain professional, please let us know. Also, if you're looking for more information on how to implement this or how maybe this technique can benefit you and your teams, reach out to us. We definitely love to discuss this further. And on behalf of all of us here at Arqiva, thanks again. Have a great day.